So today we are going to start off with a new chapter, which is by the title Kinematics, and one of the trickier ones, especially from the syllabus of AS. So as we start off the chapter, you'll find out some of the content is just being carried forward from IGCSE or O-level physics. So this is data sheet you're provided in your question paper itself, formula sheet as well. So some of the definitions we are going to just fast forward these. We start off with the difference between scalar and vectors, and these are the differences. What are the similarities? The two similarities are both have magnitude and both have unit. Okay, many of the students, when they ask the question for similarity, they are only able to come up with the magnitude. The other similarity is both of them, they have the unit. The next one we have is distance against displacement. So once again, we're going to carry forward this, fast forward. Distance is the length of the path as you move from one point to another. So whatever track you have covered, if you measure the length of that track, that would be the distance. However, distance covered in a specific direction from a certain point is called displacement, or in simple words, we call it the shortest distance between 2 points. So if you cover the distance in a specific direction and you do not change the direction from one point to another, so you have covered the displacement. So for example, point A to point B. If I move in a straight direction from A to B, then that would be displacement. So distance is scalar, displacement is vector. So since this distance is a scalar quantity, it would always be positive. Scalar quantities are always positive, and displacement can be negative, it can be positive, and if an object has moved, it must have also covered some distance, but if an object has moved, the displacement might be 0. For example, this is point A, an object goes from here over there and then gets back to the point A. So 3 kilometers on this side, 5 kilometers on this side. What is the distance? 3 plus 5, 8 kilometers. What is the displacement? Since your starting point and ending point is same, so your displacement is 0. So it is possible that an object moves but the displacement is 0. For distance, it is not possible. Both of them are measured in the unit of meters, and if we talk about the symbol, the distance is represented by the symbol S. S is there to represent the word spatium, which is a Greek word that means the length or the track or the derived from space as well. So spatium, starting from S, so is the symbol of distance, and displacement is represented by small d. Now, like I said, displacement can be negative as well. Now, what does that negative sign represent in displacement? That represents the position of the object with respect to the origin or reference point. Your reference point can be origin, it can be any other point as well. So it tells you about the position of the object with respect to a reference point. And I'll explain this thing in the topic of sign convention. We'll study when the displacement is positive and when it is negative. So if we compare the magnitudes, first of all, this thing is read as distance is greater than or equal to the absolute value of displacement, or you can say distance is greater than or equal to the magnitude of displacement. So what we are saying is displacement can be negative, but we are trying to get rid of the negative sign And in mathematics, if we take the absolute value, for example, we take the absolute value of x, so even if your answer was, let's say, plus minus 5, you'll always be taking the positive value. So absolute value means the value without the sign, just the magnitude. So distance would always be greater, or it can be also be equal to displacement, but distance can never be less than the displacement, because that would be a violation of the definition of displacement itself, that displacement is the shortest distance. So if you have a distance which is even shorter than the displacement, then that would be that should be called as displacement. So in what cases the distance and displacement can be equal? For example, you gotta move from point A to B, and you walk in a straight line, just straight from point A to B. So whatever your distance is, the same would be the displacement. If you're moving in a straight line, in that context, these two would be same. A particle moves along the circumference of the circle from P to Q, as shown. Find the displacement and the distance moved by the particle. Now let us find the distance first, represented by S, and we'll find displacement afterwards. Now, this is your starting point P, and Q is your end point, and the object is moving it along a circle, and this angle is 90 degrees, and that tells you the object has moved quarter of a circle. So whatever the full arc length of a circle is, the object has moved only quarter part of that circle. Now let's say the object had moved a complete circle, then how much length or how much distance would the object have covered? It would have covered the distance equals to the circumference of the circle, 2 pi r. From point P back to the point P, the arc length in that case would be the circumference of the circle, which is 2 pi r. But since the object has moved only a quarter of a circle, so only the fourth part of the circle, then you can hit it on the calculator. Pi as it is times the radius divided by 2. Okay, after simplification, this one cancelled away, and then you hit it on the calculator, you get 5 pi. Then you can add the value of pi. Just press the symbol of pi on the calculator, press equals to sign, you'll be getting the answer in centimeters. Sometimes they ask you to give an answer in terms of pi, so you can leave with 5 pi as well. Otherwise the answer would be 15.7 with the unit of centimeters. Now let's talk about the displacement, represented by D. Now, like I said, displacement is the shortest distance between these 2 points, between the starting point and the end point. So if I try to draw the shortest distance between these 2 points, it would be a length, the track would be this. Now you see we have formed a right angle triangle, and this is perpendicular, this is base, and what you need to find is the hypotenuse of that right angle triangle. So we can use the Pythagoras theorem, and that tells us x equals base square plus perpendicular square and then the square root of it. Okay, hypotenuse square equals to base square plus perpendicular square. So what do you get? You get square root of 200, which is 14.1 centimeters. And you see in this case as well, your displacement is less than the distance. So that is going to be the case always. Your displacement would always be less than the distance, and in some of the cases it can be equal, but it can never be greater than the distance. Okay, let's consider another example. So I'm not going to raise it off. Okay, so in this situation, this is our starting point, the origin. itself. So the motion is in such a way that first we move towards the point K, from there we move towards the point J, then we move back towards the point K, and then we go through the point, the same one, L, then we move back to the point M, and then we get back to the point N. So this is going to be the direction of motion in this diagram. And the distances between these points, the lengths between these 2 points, or all of these points, they are given in the diagram. Let us talk about the position O to J. For the position O to J, what is the distance? So we moved from here all the way here. What is the distance? 100 meters. So distance is 100 meters. Now what is the displacement? Well, the shortest distance between this point O and the point J is also 100 meters. So the displacement is also 100 meters. Now after that we move from point O to J and then back to K. So we call it point OK. But OK, we don't move from here to here. We continue the motion. First we move towards the point J and then we move back to K. How much distance has been covered? Well, you have covered a distance of 100 meters. First moving from here to here, and then as you move back towards the point K, you covered 60 meters extra. So the total distance was 160 meters. This one. But if you have to tell the displacement between the points O and K, now what is the shortest distance between these 2 points? It is the total 100 minus this one distance. You subtract 60 from 100, you'll be left with this distance, which is 40 with the positive sign. Then O to L. So O to L is basically the same point. This is the same is a point O, the same is a point L. So first we move towards K, move towards L, then we move back towards K, and then we continue moving to the same point. So 100 meter going over the right side, 100 meter coming back to the same point. What is the distance? 200 meters. And what is the displacement? 0, because this is the starting point and the same is the end point. So whenever you get the same start and end point, the displacement is 0, because the distance, the shorter distance, does not exist. Okay, then you have from O to M. How do we move? We move the same way. So we move from here, this point, to J, back to L. So 100 plus 100, 200. Then we move 80 meters to the point M. So how much do we move? We move a distance of 280 meters. So 280 meters over here. Then let's talk about the displacement. Now displacement, it would be represented by shortest distance between these 2 points. How much is that? 80 with the negative sign. Negative sign because we are on the left side of the origin, which I'll explain in sign convention as well. But this one would be negative 80 because you're on the left side of the origin. So now we move from point O to N. How? First we move from here to here 100 meters, back over here 200 meters, then over here 280, then 50 from M to N. It would be 280 plus 50, which is 330. Now let's talk about the displacement between O and N. So for the displacement, you have to measure the shortest distance. So this one. So the total was 80. From the 80, you subtract this distance, which is 50 meters. You'll be left with 30 meters for the displacement, but with the negative sign, because this point is on left side of the origin. So the displacement would be negative 30.